For the second video on assembling the Sash clamp, we will be looking at the improvements made to width mates and how a new feature called temporary fix can make the assembly process easier. So, first thing we need to do is bring in the threaded bar. Here it's called thread. Thread bar in place. Select the end of the bar. Select the inside of the head, except with a concentric mate, and move it further into position. To get the rotation on the bar, mates and mechanical mates, we select screw. And at the minute it's revolutions millimeters, we're changing that to distance in revolution and change the 1 millimeter to 3 millimeters. We will select the threaded bar, and now we hide the threaded bar because we have also to select the threads on the head part itself. But as we select the threads on the head, we can see here that when we select the second, the measurement jumped back to 1. So we change that to 3 again. 3 millimeters. And zoom out, we can see an arrow going in a clockwise direction. So that's the way we want it, because that's the way we designed the threads. So we're going to accept that. Now, we hid the thread, so we need to bring it back in again. So now, as the threaded bar moves along the head by rotational movement, you can see the threads are working. And accept again. The next part now that we have to mate is the inside of the hole on slider 1. Select that. And we give a coincident mate between those two. And we've also to insert a pin in here. So we will do that now. Insert pin, and to insert a pin, mate, advanced mates, profile center is one I like using for this. So select the circle that's going to make contact with this circle, and I'll just click on the lock rotation button there. Now as I rotate it, moves in and out. The next part to insert is a Tommy bar. So select the Tommy bar, bring it in place, and I'll just rotate the threaded bar just to line them up. Once again, I'll use the Alt drag and accept. And we can see now the Tommy bar is in place. moving the tommy bar, I'm not quite sure whether the tommy bar is fixed within the boundaries. I know it isn't because I didn't apply that, but it makes it very difficult for me to see its range. So for that, I'm going to use the temporary fix feature. So move component, scroll down, temporary fix, and I will select the threaded bar and resume drag. Now I can see that the tommy bar is concentric with the hole, but it's free to move outside its boundary. I will have to fix this. So we go into mates again, advanced mates, width mate, and instead of centered, I will give it free. So when I scroll up again to the top, it's asking me for the tab, the width selection. I want to be able to move freely from that end to this end. And tab selection is the threaded bar. So when I accept that, I should have rectified the problem. But once again, I'm not sure whether I have, so I will apply my temporary fix again. Move, temporary fix, select the threaded bar, resume drag. Now I can see that once either end of the tommy bar hits the cylinder of the threaded bar, it stops. So that's its limits. So I'm happy with that. I'll accept that. So as I rotate, I can see now there is another problem. So once again, I go to mates, advanced mates, select the width. I will activate the distance mate, and I will change its distance to 95 millimeters and range it from 95 to 0. Two faces that I will select, the slider 1 where it touches the head button, and accept that. When I move the slider, we have its limit. And I will also apply a width mate to slider 1 and slider 2. Mate the width, and this time the width between the face of slider 1 and slider 2. And I'll make the distance between them 100 maximum, and 0 is the minimum distance. Slider 1 and slider 2 also does not pass through each other. So as we can see here, the improvements made in 2015 on width mates and the additional feature of temporary fix improves our experience in the assemblies. That is the end of this task.